These are the best batteries on the market. No, these are the best batteries on the market. I always use these batteries. They're the best. These batteries, they're the cheapest. These batteries, they're better than all of you guys. No, this is the battery. This is the way you need to go. Welcome everybody back to Just Plain Crazy. I'm Brendan. Thanks for joining me again down here for another episode in the lair. The weather still stinks outside, so today is going to be a great day to talk about batteries. Mainly the lies and misinformation on the labels, mainly those C ratings. You buy batteries just because of C ratings, you've been misled, and I've been misled. Does the word graphene make you want to buy those batteries? You've been lied to, and I've been lied to. We're going to learn a ton about batteries. Stick around. Start up the car, Ma. We're fixing to get into a fight. It's time to talk about one of the two most controversial subjects in the RC field today. I gave you guys a video recently on the Jetty DS12. People have very strong opinions about transmitters and batteries. I don't play Homer Favorites to products. Don't just buy this because I have it in my hand. I give you good, honest reviews and what I see as the highlights and the downfalls of every product. With the Jetty DS12, I gave you all the highlights. I don't bash the competition. I just simply show you what it can do and implore you to ask, hey, ask the competitor, can you do that? Why can't you do that? Or does it fit your basic needs? So today we are going to talk about batteries. And I particularly want to talk to you about SMC batteries. I recently picked up two of those from SMC-racing.com. Check those out over there. I am going to give you my opinion on these batteries, and we're also going to talk about all the truths around batteries, lipos, their labeling, and what that information really means. I have a good friend of mine who taught me not too long ago. He's an engineer, and there's an old saying in the engineering field, in God we trust and all others bring data. That's what I want to bring you on batteries. This is a hard subject to talk to people about. One, because they have vested opinions. They feel strongly about this stuff. The other part is because it's hard for you to see what's really making these things up. So we have to clarify some of the truths and mistruths when it comes to batteries. And I really hope you stick around for all of this because there's a lot of really interesting things to talk about here, believe it or not. And then in future videos, we're going to do a lot more testing out there in the field to really show you what we see. These batteries, when it comes down to it and all the strong opinions around it, really comes down to when you ask that question, you're going to get 30 different answers because people fly differently. Even with the same planes, they like their CGs different. They fly faster, slower, high alpha, a lot of downlines, a lot of strong uplines. I fly slower, you fly quicker. The way your plane carries energy through rolls, loops, the way you use, all those things affect two planes with two identical batteries, and they get two completely different end results. So I want to talk to you about a lot of testing that got done to all of these batteries. That is all linked down in the description below. We'll talk about more of that later, but there's a lot of scientific testing that has gone into these, not my opinions. I'm going to downsize that information and share with you a lot of the things that I've learned over time and just recently, and hope to educate you to make a better battery buying decision to make your flying a little bit more pleasurable. So let's talk, guys, about the labeling on batteries. All of the batteries that you see here before you, Roaring Tops, HRBs, Panther Graphenes, Heavy Duty Turnigy Blue Packs, Z Packs, and these SMC packs, they're all 6S packs. 6S, 5S, 4S, 3S, 2S. How many individual cells make up this battery? We'll keep a lot of the information as simple as we can without going into 1P packs, 2P packs, and confusing and muddying the water, if you will. So let's just first talk about, 6S, 6-cell pack, right? When you talk about 5,200 milliamp hours, that means how big is my fuel tank? How big is my gas tank? So the bigger that number, the bigger the fuel storage area, potentially, all right? Doesn't necessarily mean that battery is really going to hold that. This may be a 5200 that really only has 4,000 usable milliamps in it. Not saying it does or doesn't. I'll let you guys see that all that information for yourself. And then we talk about the C rating on batteries. Note right here, this is one of the biggest lies in the battery industry. There is no set standard procedure for measuring C rating. So how do I get you to buy this battery over this battery? There's a saying in the retail world, you better be the best or you better be the cheapest. So if I have a battery that's advertising higher C ratings, 50C, and there's no standard, I could easily go ahead and tell you this is a 60C pack, and it is. I can also tell you that that's a 120C rating in a burst. So if it has a 50C, that means that this battery can continuously, without damage, put out, all right, 60, and you would think that's 60 amps. It is not. There's math to it, and we'll discuss that in a minute. But it can put out that much amperage without damaging the battery. In burst rating, 120C. That means that's what it can put out in burst without damaging that battery. The math behind the C rating is simply this. There is 1,000 milliamp hours and an amp hour. So if this is a 5,200 milliamp hour pack, we're going to divide 1,000 into that, and we are going to get 5.2 amp hours. Let's make the math simple. If we use this one, this Turnigy, this blue wrap pack, which everybody's very familiar with, this is a 5,000 milliamp pack, so it is a 5 amp hour pack. So if I take 5 amp hours and I times that by my 60 C rating, that means continuously I can put out of this battery 300 amps continuously without hurting this battery. It has a burst rating of a 120C, which means double that number. So this battery can put out bursts of 600 amps without hurting itself. With that being said, let's start to make reason of those numbers. This is an XT60 connector. This connector can only handle 60 to 70 total amps of current before the connector has damage. Here is an XT90. This thing can hold about 90 total amps of current without damage. Most everybody flies with a lot of XT90s. You have EC5 connectors. So these things are about 130 amps of current before there's damage. And what I fly with, the AMOS 150 anti-sparks. So those are 150 to 160 amps of current without damage. If your connectors can only flow 150 amps, how are you ever going to flow 160, 150, 300, 600 amps out of a battery? It doesn't add up. Doesn't make sense. You want to get more fuel in the tank? You want to get more milliamps into your battery? Charge it slower. Lipos are recommended to be charged at 1C. So this 5200 should be charged at 5.2 amps. It ramps up and it ramps down most chargers, so it's not that consistently. And a lot of people, I'll charge mine at 2C, 3C. It's been scientifically proven. You charge them at 1C, yes, it takes longer. Your batteries will last longer, period, but it will also fill them a little bit more. Sometimes a little bit more for us is a good thing when you got to squeeze in one extra landing because you needed a go-round, right? The other thing that's been proven is that if you charge these to a little bit less than the 4.20 that we're used to, they'll also last longer. Do you want these batteries to last longer? Prevent them from puffing, swelling up. When you get a brand new pack, believe it or not, when they're compressed, you charge them up the first time, get all that energy in there and start to use it, these packs will expand a little bit, all right? That's normal. We all know what a big puffy pack looks like, so what causes that swelling? That swelling is caused by a bad application. So number one, your system is requiring more than what that lying C rating can give you. You're pulling more current than that battery is capable of getting, and you're killing it. The other thing, you run it down too low. You're taking more out of that battery than it has to give you all the time. So running cell voltage down too low is definitely hurting this thing. One of the last things, don't leave these things laying around fully charged. The easiest way to think about this, it's a balloon. You go ahead and you blow up that balloon, it becomes less stable and more fragile, and you leave that balloon sitting there with all of that energy, and you put that thing away. That in itself is not only dangerous, but it's also very bad for that pack. How do you get the optimum lifespan out of a battery? Maintain its temperature. So according to Joe, under 131 degrees is the right temperature to keep a battery. And we've talked about some of the ways to keep it there. If your battery's getting hot, something's wrong. So let's break into one of these SMC packs. Let's open it up, see what the inside of this thing looks like, and talk about what makes these things so special. Some of the biggest points or biggest talking points to this battery or their line of batteries. Number one, the mastermind behind SMC has been doing this, developing and testing for over 33 years in the battery industry. He knows his stuff and he has a very diverse background. On top of it, he's done a lot of testing through a lot of different manufacturers with different chemicals. He's pushed them to come up with some of the best chemicals in the industry to have the best results for us to put in our RC products, whether it's airplane, it's flight related or ground related. He has the lowest resistance packs on the market. So what it really comes down to is he has the highest watt per gram in battery power. What that really means is the most amount of power you are going to find with the lowest weight in a Lipo battery. Because he's pushed his suppliers to give him the best products out there and the lowest resistance, what does that mean to you? Real current, real C ratings, longer flight times, cooler running batteries, which means they are going to last longer. SMC carries a 1-year true warranty on their batteries. So that, of course, like anybody else, that doesn't include damage or abuse. That actually, takes into account a real failure of some kind because they believe that highly of their product. So let's go ahead and open this bad boy up and take a look inside. They come in these nice black cardboard boxes. We got some foam in there for protection. Got some decals, got some stickers, right? Some destructions. We got our batteries, some more foam in there. And notice that they have the discharge cell rating or the storage charge rating written on the inside there, so some quality control. The leads on here are silicone. They are 10 gauge on this battery. This is an 8100 6S pack. Now, these connector ends, you can order in various type of connector ends, whatever suits your application. All you have to do is order them that way. To me, it doesn't matter what's on there because they're all getting cut off. These are 5-inch leads with a 1-inch connector. The balance leads have these nice pull casings on them, which are becoming popular now to protect your wires from breaking. I see a lot of complaints going across Facebook and things like that because I can't get my cells to balance. Number one, that may be the start of a short in a cell and a bad cell. So when you're using the pack and all the cells are coming down to 3/7, 3/8, that one cell, that didn't get charged. It's crashing all the way down at 3.2 and causing some type of low voltage condition and possibly a crash or a failure. So not only is it important to always monitor total pack voltage charged, do yourself a favor and I'll look at individuals. Make sure that they're all at fully charged state before you throw it in a plane and take it up. So I've seen cells that start to short out to do that, but also these balance lead wires will start to fray or break, and that causes the same type of situation. These batteries, guys, they're solid. G10 plating in the side of this thing. Those plates add 5 grams. That's it. And when you're already dealing with a battery that's super light compared to its competition for usable power, a little bit of plating here is a little bit of protection. Why do I need protection? He has batteries that are just on the sides, all right, that are plated right there and right there. Why not here and there? Because if we look at other batteries that are see-through, all the cells are folded over, so they actually have multi-layers of protection there and there. And why is that good for me? So plates are there for protection. We have folded over extra material here and back here for protection. And that protects me against drops. That protects me against possible dings, maybe some crashes in the car market, maybe protects me for some T-bones. But like I said, depending on the battery, some batteries are built with the plates in between every layer. These are just on the side. but they're not really adding any weight to your battery. These things have been tested across the board through that RC groups page. Talk about that just in a second here, as true C ratings. So this C rating, this 8100, is a 20 C rating. And I'm going to stick this in my Carf 330 Extra Special, 2.3 meter, 93 inch, 22 pound airplane. That thing has a 25.5 by 13 prop on it. That thing pulls at times up to 120 amps. How am I going to get away with a 20C pack? True 20C all day long. These packs have been tested between 30 and 35C, depending on exactly what pack you go with. So even at 20C, let's break that math down again, even if this was just an 8,000 milliamp pack. So we're going to break that down to 8 amp hours. 8 amp hours times 2, 160 amps continuous this battery can put out without damaging itself. I'm only pulling 120 amps. Again, values of telemetry and knowing your setup. So why do I need to pay for a 50C pack if 20C is going to be enough? Your connectors couldn't handle it anyway. Some of the mistruths in the labeling. And his are actually better than what he's putting on there, or at least exactly what he's putting on there. Guys, how can you go wrong? So these things, I'm going to put in my Carf, and I'm going to put them to the test. And as soon as we get rid of this garbage snow, we're going to be dumping some of his packs into some EDFs, and we're going to be doing some field testing with that alone. So with that being said, I had in these HRBs, they're 50C packs, 6 amp hours times 50. So that's 300 continuous amps that this battery can put out. Yes, they worked, but why did I spend the extra? And were they really a true 50C rating? I'm going to show you I was lied to. So it is time to talk about the nitty-gritty of the testing. Not the way I feel, not my invested feelings or interest. It has to do with straight, honest testing. Over on RC Groups, there's a forum that was started by a gentleman by the name of Joe Diamaggio. Hope I didn't butcher his last name. This guy has some real good, solid scientific testing going on there. There's been a lot of contributors into that page with a lot of great information. Joe's testing procedures have been found to be good, solid, sound, honest testing procedures, and he uses them for a large variety of batteries. You don't see yours on that battery list? Well, maybe A, it didn't make the list, or B, maybe he hasn't tested it yet. So you want to send him yours? He'll actually go ahead and test it, and they'll post the results. Jim Kidd is another fine gentleman who does all of his data population for him. Amongst the battery industry, there's a lot of guys that have come together to put together good, honest information for us to look at. Most of us don't even know it's there. I don't have to do it. I don't have the time to do it. I want to go flying. I'll take their word on it. Show me some proof in the pudding. So they did it. Let's take a look at it. One of the things that you guys are going to see is going to be bubble charts. On the bubble charts, he has them listed, and all that stuff's in the link below. He has them listed alphabetical order here at a 25C test, a 30 test, and a 35C test. And you can find yours listed in alphabetical order on this list and see how it fared out. There is on page number 2, which I've also included, there's a legend at the bottom. And you guys can see it's one of the best if it's solid green, average if it's half. If it's an empty circle, it's just average. Half the black is below average, and then if it's solid black, it's one of the worst. When we look at some of the batteries that are on here, you just take the Admirals at the top. They tested okay, but as they got higher, they fell off. What about those HRBs that I'm using? The HRB 50s in here, even at 25C, they don't test out so well. You start getting up to 30C, 35 real C needs, and boy, they're really suffering. So are they hurting the power in my Carf? Very potentially. So you can go ahead and see if you can find your battery in there and see how it stacks up. One of the other things that Joe and Jim have populated in this group is an impression chart. In the impression chart, you're starting at the top and working your way down, looking at some of the best batteries in the bunch. And you see these are actual test results. So number one, he gives you his impression based on what did the battery say it could do versus what it actually did. So SMC, he found to be one of the most accurate by what they actually label their batteries. SMC, it's at the top. SMC at the top. You got a Dynegy in there. You got a Panther. Then you got a Zippy, an HRB 100C. You got another SMC, another SMC. There's another SMC. So in the top 15, I'm seeing 5 SMC packs. That's pretty good, honest testing results right there. And what we're looking at, represented C. So on his pack label, 20. When it was actually tested, it was at 30. There was another SMC pack. The represented C was 40 on that one. The real C on there was 35. Not like some of these other ones down here at the bottom. So you have a max amps battery down here at the bottom. Represented C, 120. Actual C, 10. That's not so good. And then we can actually start to look at represented milliamp hours, 8,000. How many milliamps were really available in his pack? 8,021. So when you break down the price per amp hour, the actual amount of energy in that battery that you can use, that you're paying for, that's actually broke down in dollars per amp hour. And it winds up being $1.41. It's not the most expensive on that list. What does that mean for you? That means you're overpaying for batteries. I'm overpaying for batteries. Maybe you got lucky. Maybe there's that pack that you like that flies well. Maybe you got lucky and it's on top of the list. Maybe that plane that you thought's a POS, maybe it's the battery. It's not the plane or the power system at all. So SMC totes what makes their batteries better is what they use on the chemical makeup on the inside. They tote that they have some of the lowest internal resistance readings for batteries. That's what makes them last longer. That's what makes them lower temperatures. That's what makes them have more current flow for more power and true C ratings. I can't do scientific internal resistance testing here, and I think that when it comes down to it, I don't need to, but I would like to actually see how these compare to all the other batteries that I have in my arsenal. And I have something interesting to show with you guys. So I don't want to split hairs about the right way or the wrong way to test internal resistance, because as temperatures are higher, lower, all those values change. Is it a little bit more charged this way or undercharged? They change. I took everything in its discharge state, in a storage state, and I put it on my X4 High-Tech, and I got a milliohm resistance reading on there. And I want to share with you something very interesting that I found. So number one, when we look at the internal resistance readings, the roaring top that I had, 10 to 12. The Z-Packs, 4 to 6. HRBs, 4 to 5s. All the cells ranged within there. Turnigy's, which actually rated fairly high on that list, 1 to 4. So they were lower than the others. Here's another Turnigy. That's in that range as well. And here's SMC also, right at the bottom of that internal resistance rating. And again, comparison data, things that make sense to me. Testing like things under like condition. I don't need to know exact numbers because I'm sure that those numbers could be more scientifically exact. But what it helps me to do is compare why one is better to the other. But what I found out, the very first one that I had you guys look at was one of the most interesting. That was that roaring top. I don't know, where'd that thing go? Right here. I paid a lot of money for these batteries. And one of the things that I notice about these batteries, they're not swollen, they're not too beat up. But that internal resistance reading is 3 to 4 times what all the other packs were. When I use these, I only use these in my F-14 Tomcat. When I sweep the wings on that thing, it's typically flown at full power for 2 to 3 laps. What I started to notice about that plane is after the 3rd lap, it seemed like I was out of battery and I had to land it because I could feel it slowing down and I wasn't getting any more power out of it. Now that I see what that internal resistance reading is compared to all of these other ones, I'm getting these hot and I can't flow the power through them. I need to upgrade these batteries. So let's talk about the overall weight in the SMC packs. I went ahead and I tested all my packs and I weighed everything out using my super accurate, forever, my faithful, trusty Amazon scale. Okay, so it's like 10 bucks. It's probably not all that accurate, but it gives me a close idea. Anyway, I use it all the time and everything. I weighed out all of my batteries compared to what they did here just to see if they were consistent. I was within plus or minus 5 grams of everything that they tested. So I'm sure that their testing equipment is far more accurate than mine is. But that tells me that the weight comparisons are pretty honest in this review. I want to use these packs, even with these plates on them, in my Carf. I am putting in battery packs that are 2,000, 2,100 if you want to be exact, 2,100 milliamps bigger than these HRB 50Cs. The C ratings in these turned out to be a lie. These are actually better than what they're saying they are. So that means that I don't need to waste all this weight in this supposed C rating because I have everything I need right here. The difference in the battery weight from this one was 833 grams. This one with 21 extra 100 milliamps and some protection in the sides come in at 901. So really 70 grams difference in between those two batteries. In this plane, I can actually use the nose weight to make it balance. But if you need weight, I would rather gain weight instead of putting in dead weight like stick-on weights and things like that. We move and slide batteries. Or, if you need to, carry more milliamps. So I'm going to get a lot more flight time out of this battery with 8,100 milliamps and true C ratings than I will out of this thing that's been lying to me the whole time. More flight time is more fun. Let's talk about figuring out your flight times. Can you actually use that milliamp rating if it's accurate? Again, we're going to check the chart over at RC Groups. We're going to see if the battery that we have has a represented accurate milliamp reading. We can use that to determine flight times. How do we do it? Simple. Take this battery, it's a 5,000 milliamp hour battery. We're going to break that again down into amp hours. So that's going to be 5 amp hours. How many minutes are in an hour? 60. So we're going to take 60 minutes times that 5 and we get 300 amp minutes. 300 amp minutes divided by how many average amps you pull. So through telemetry, again, the values of that Jetty telemetry, gotta love it. And I can go back and actually look at all of the data from all the flight, as many flights as I want to. It's all held in there. So anyway, Jetty win. With that being said, this thing, if I know that I have, all right, 300 amp minutes, and I am pulling 30 amps average, you divide the 30 into the 300, I get 10. That means on this battery, I should get 10 minutes of flight time. So if you're using an amp hour sensor to measure used milliamp hours through that pack, that's the most accurate. If you're going to use the timer, at least if you break the math down and you know that you can trust the label that's on there, which we're finding out we can't, unless it's in a true battery pack like our SMCs, then we can maybe figure out the actual flight times. But that's how you do it, and now you know what to set the timer to. You buying batteries because they have the word graphene on there? It's a trade name. It has nothing to do with pack chemistry. Either way, it would be really, really light. What makes these packs so big and heavy? Well, it's the way they design these things. It's the density and the way they make the pack that actually makes them better. It has nothing to do with that fancy logo on the top. So if you've been buying batteries for this logo and spending a lot of money just for that word, you've been fooled. I've been fooled. These batteries, they work pretty good, but they're big and heavy. So they may work in my Carbon Z in a plane like that can handle and use the extra weight, but this doesn't work in everything. Weight's a killer in a lot of planes. Want to know if that battery is going to be a good fit in your plane? Joe notes in his testing, one of the questions he gets asked the most that he writes in there is simply, is this battery a good fit? So he has what he calls the kitchen table test. You are going to go ahead and charge that battery up to full charge. You're going to put it in a plane and you are going to run it at wide open throttle. You are going to use a cell checker on the balance leads. Why do they do it on the balance leads? Because it's the most accurate and closest to the individual cells, rather than doing it through telemetry where you're going to pick up resistances and voltage losses through connectors and solder joints. You do it right at the balance lead. Now, I have this little handy generic cheapy cell checker. They actually recommend something a little bit more technical. There's an ESR meter that would be the best way. Link in the description below. But this thing will kind of give you an idea. So You go ahead and run this thing up for 5 to 10 seconds at wide open throttle. While it's still running, you hook this up to the balance lead, and you are going to check individual cell voltages. Those voltages should stay between 3.8 and 3.9 and be no different than 0.02 of a volt from each other. So that's 0.02. Anything up to a difference of 0.05, 0.05 of each other, is still okay, but not ideal. One of the things that he says to look for is to keep an eye out for any battery that can't hold 3.6 volts per cell in that 10 to 15 second window. That isn't a good battery to fly. He notes also that the ideal battery should be at least 3.7 at wide open throttle for up to 30 seconds. That is some pretty good information to help us to actually make the right decisions about, is this battery good for this plane? You should take care of your lipos. It's going to affect the lifespan of them. It's going to affect the amount of money we keep in our wallets. And hopefully we know where to get good battery packs based off of scientific testing that Joe, Jim, and a bunch of great other guys have put together for us over on that RC Groups page. Again, link in the description below. Head over there and check them out. As far as these batteries go, I really like the true honest labeling on the SMC packs. We're going to do a lot more field testing as I start to pick up more of these and change out some of the other fleet, especially these expensive roaring tops. I guess they gotta go. If you guys are actually interested in picking up some of these true, honest labeled SMC battery packs, I want you guys to head over to smc-racing.com and check them out. True, honest labeled packs. We're going to put them to the test. We're going to put them in lots of planes and try them out as we can start to swap out our battery supply, if you will. But I'm pretty excited to get to testing these. We're going to throw some sets in the carfs. We're going to pick up a couple more and throw them into the EDFs. I really like what I see on them. I hope you do too. Please don't go look at SMC packs because I have them in my hand. Go look at the data, look at the bubble charts. All that data is included for a quick reference down below. Print them out and take a look at the information for yourself. You're probably spending more for proprietary packs than you would for one of these, and they actually tested much, much better through good, honest test results. I don't have any special links. I'm not asking you to buy to help me out. I'm just showing you great product, honest labeling, good quality built packs. All right, guys, and there you have it. It is Brendan at Just Plain Crazy. If you liked it, smash that like button for me. If you didn't like it, I don't know how. There's tons of great stuff here. Comment down below. Tell me what you guys thought was the greatest tip or piece of information that you found helpful. That always helps me in the process of putting out information for you guys. Make sure you share away on this. Let's get the word out as to what real labels really should look like and mean, and maybe one day we can help to change the industry so we're not being lied to anymore. That includes you and me. Go ahead and make sure you hit that bell notification and select all so you're made aware of all of my content as it comes out. There's tons of cool projects coming up. I'm so excited. I can't wait. With that being said, I wish you guys happy flights. Peace out.